the rest of it will run autonomously, and we'll all be happy. So
I see Bill has his hand up.
I've got a star too, so let me interject at the appropriate time.
okay.
All right.
I have a short thing that I'd like to do. If my audio is working after the stars are done, I have a short discussion that I'd like to conduct pertaining to my exciting little memo that I wrote to the list. I guess it was yesterday evening. Wow. Okay. All right. So on that cheerful note, on with the challenge. Brad, you're on. All
right. Well, so I decided to accept the proposal to do it with a haiku, as that seemed like a fun thing to go back and do. And the first challenge, of course, is that the fourth haikus don't have text built in. Right, everything is just that X, Y, and T and drawing thing. So I had to draw an asterisk. And so I defined a few words to sort of help me. I used the words. I defined the word square, and then the word ang, which is given an x, given the xy coordinates of the space here, return the angle in radians, and then a distance operation, which given a position on the screen returns the distance squared actually from the center. And then initially I thought, well, I can just divide the angle by pi, multiply it by 2.5, subtract off 0.25, and then mod it with 1. And if that's greater than 0.5, that gives me these sort of radiating arms outward. You can sort of see what that would look like if let me delete part of the thing here. So that gives me something like that, sort of spanning out. And then the bit that I added in is to then limit it by distance and it, so that essentially clips it to a circle. So that was my initial asterisk. But the problem is that that's not a very reusable asterisk. So I went back and revised it slightly so that the angle and distance operations take an XY value on the stack instead of assuming that it's those global X and Ys. And then I broke this down into a star word that works all on its own. So you can get an XY coordinate and then give yourself a star. I then went ahead and actually let me sort of do a derived work to give you an idea of what it would have looked like. I then said, well, okay, but I want to have lots of asterisks. So what I could do is multiply x times 25 and then mod it with 1, and let's say multiply y by 25 and then mod it with 1, and that will repeat the x and y's over and over and give me a field full of asterisks. So then I get multiple asterisks to play with, and then I then sort of just riffed on that theme. A couple of different things that I did there. I defined, I renamed star to asterisk because I later realized that was confusing to call it star. And then the actual outer star, I can't take credit. Sadly, I scratched my head for a little bit and was struggling with the math of a good way to do this outer star shape compactly, and I went and said, well, let me go look at what other folks have done, because there's lots of stars on the haiku system, and I found a fairly compact version of a star from this fellow dark star, and I actually cleaned it up a little bit and compacted it sort of for my purposes, but it basically gives me a stencil that is this star shape. And then for the different RGB planes, I trimmed out and selected just a portion of it. And then I also took the shape of that stencil and then sort of drew the outer edge of that stencil for the red and or for the green and the blue plane. And because it's a kind of a fuzzy stencil, it has a little bit of a glow to it, which gives the star a nice glow. So I can't take credit for the actual star stencil, but the sort of the composite, I guess, is my doing. And then I thought, well, it's nice to have a star, but I should put it on top of a tree. And so I went ahead and built a tree out of Asterisks as well, and it's a similar idea. I took the Asterisks and then made a different scale set of stars. So these Asterisks are bigger, and then applied just a triangular stencil, and then I did a similar thing, but with instead of doing mod 1 as you saw with the field, I did a mod 4 or something -2. Which lets me space out the Asterisks, and then I also added this word light, which is just an inverse 1 minus the distance, which gives me kind of a glow, and so I get a little glow for the decorations on the tree, and put them in the appropriate planes, superimpose them with the star, and then there you have it. So a little bit big and a little bit kind of lumping things together, but Christmas star. Any questions? Over to you, Bill.
I'd like to thank Brad for not blinking the lights. Thank you, Brad. Bill, you're up.
That almost sounded like a suggestion.
No.
Okay, I feel guilty about following that. It's like in vaudeville they said never follow a children's act because you'll never meet their expectation. And so I'll be doing a star, but it's pretty modest. Anyway, so here's my seeing stars. That's good. All right, this is the barest minimum you possibly could do with the teeniest tiny go-to. So here is my modest offering. So I took the same starting point that Brad did, and we're going to see a dramatic difference. So my tools, when everything's a nail, when you're working on a nail, everything looks like a hammer. Well, so I got 1/32/4. In it, it's got go to XY. I then used Zoom to record the plotting that I did, and then I used a Prism Plus to edit. And I do recommend very highly this NCH family of products. They make about 20 different single-purpose pieces of code. They're all reasonably priced, and they've got utilities like editing, sound, CD copying, graphics, and so on. Very, very functional. And so I did a very simple edit with this at the end using their software. So the grid I'm working on is the coordinates are 100, 100 at the top left, and then at the bottom right is 600, 400. And if you divide by 10, you actually see these are the lines, vertical lines, and the horizontal are the spaces across the screen. There are variables necessary to define a line. You need the beginning and the end, and then along the line, you need the current position. Where are we at the plotting at the moment? The first word used is to locate XY. So given a current X, it will locate where the Y is. And it's just interpolation along that straight line. You expand on that to develop an XY plot. And in this case, you give it the current X value and Y value. These are scaled, divide by 10, and you plot the point. And you see the ASCII star, it's emitted, and then a 25 millisecond delay because it makes the plotting easy, more interesting. Otherwise, it's instantaneous, not too interesting. To plot a line, very simple. You know the beginning point, the end point, and the current. So in the do loop, we locate the current XY point, we plot it, and move to the next point. at the last two lines sets the current value to the new origin. So at the end of plotting each line, you set the origin for the next line. This is the description then for the star. The clear screen 100 milliseconds gives a little starting delay. And then you set the origin, in this case at the points 330 and 100, then plot each line. And you notice the last line at the end ends at 330 and 100. So the pattern closes on itself. And here is the plot. And it slowed down, of course, to fit. So that is my modest offering. And the final concluding comments is that I use linear interpolation on a straight line. I will note in Win32.4 there is a bug in Go2XY. When you boot the system up, the very first usage of Go2XY will be an error. There apparently is some internal initiation has to be done. So whenever you use it, you just do a 00 Go2XY, get that out of the way. The operator is now properly initialized. There is actual graphics in Win32.4, and they are quite rich and they're fully functional, but I have not gotten that far. And so the final concluding remark is that most of my time after I wrote this, or in writing it, was jiggling around to make the points look good on the star. And you can see it's slightly offside as I ended up. I had to rescale. I did it once and it came out too small, and rebuild it larger. So that is my humble offering, and I will pass the baton on to the next speaker.
Well, I should just say, Bill, you at least actually did the star yourself instead of cribbing the star from someone else. So I'm duly impressed that you actually drew it the way you draw them by hand. That's actually a nice, like I actually was sort of trying to think through that math and actually had trouble. So.
Well,
that's a lesson
every
learned.
Time you do one of these, you learn something. You learn some stuff, and so this was my training wheels for plotting.
Let me tell you, I was impressed by both of them. I was impressed by Bill's. It was very forth-like in its simplicity, and it's not humble at all. It's much to be desired. And the other thing that impressed me about Bill's was he made a darn presentation out of the thing with PowerPoint slides, and that's like totally awesome, dude. The thing I'd like to say about Brad's is that he I would have been more than pleased if he had just laid down dots of some sort, pixels, rather than actually making asterisks. So Brad excessively complied with the requirements of the task. The other thing is that, yes, it is important to learn to look at other people's code and says, yes, I can use that. That is a good thing. That is not something that you should be ashamed of, embarrassed for, you know, especially if you do it without violating the law or hurting anybody's feelings. Yes, it is a good thing to reuse code. Just don't blow up this, the rocket, making the most expensive software failure to date. Reusing code doesn't mean cutting and pasting the thing in bulk and not producing something that works. So yes, reuse code, a good thing. So Bob Armstrong, you have a star for us, or do you want to go straight to your talk and do stars later?
Actually, I definitely guess that I want to comment on notes I've taken so far. So let me go to the screen and get back to, this was actually the original in this minimalist computing group on Facebook, which now has something like 4,000 members. But wanting to get to, I almost should shut that down. I'm going to jump and cover that over with actually a table, another window here.
All yours.
Okay.
But
Okay.
and now you're seeing mainly a blank screen with some big characters, and here are my notes, and as usual put down a timestamp for beginning. And one of the points that I do hope this is large enough. I think we're up to 30 as the font size, but
Font size is great for once, Bob.
what?
The font size is great for once. It's good zoom. Thanks.
Well, it was either this or go up to 40. So in any case, yeah, I mean, I do listen to Kevin. It just takes an iteration of, you know, it's like old punch card times. The turnaround time is like a month here instead of, it used to be a day with punch cards. Anyway, yeah, some of my notes, the issue, the thing with Bill mentioning the whole thing, I never looked at it as being, I thought of it as implementing stack frames. And this guy, George Lyons, had an article in JFAR, I see, on lightweight stack frames. And essentially what it does, and I hope this is big enough, the font's not as big over here, but essentially the major thing it does is just put the pointer to the previous stack frame on the stack with a variable, which is just a single, not here, no, somewhere here. Oh yeah, here it's going and making this just stores the previous stack pointer. And one of the things in CoSy, because essentially everything is just dynamically allocated, you know, any actual data is essentially never on the stack. So it's just one or two item, you know, it's the addresses of objects. So and I generally keep that following very much the APL and generic. The generic combinator is a Y. You've got X and Y, and you turn them into Z. So and everything can be reduced made into a list. So you can always reduce things to, you could even reduce them down to one argument, always if you wanted. But getting to Brad's, I see no counted string. So I mean, one of the things is obviously, as I've mentioned, an object in CoSy is type count and then reference count for handling the memory management. But here, this is why I like having a vertical bar. It makes a lot of sense as a comment symbol. This was just Brad's quick demo. I've got 1, 2. Well, this is just the word take. And again, the modulo indexing. Whoa, got my line on the wrong. Yeah, there's that, but this is really basic, you know, APL world word. One of the things that I wanted to, just whenever I see, and this is in Brad's code, and whenever I see traditional programming, and I see a repetition of like regex words again and again, it's like, heck, just give me, you know, let me split this out. R is this is the root dictionary, which gets stored every time I hit F6 that I execute something. So that's just the word, but I just was using it as something to just go and show how trivial it is to concatenate all your garbage and then say, okay, execute that, or throw it and stick it into the script that you're generating. And actually at that, well, this goes into the thing I think I've covered. I will mention, one of the times that I got out there to SVFIG, I was hanging out at the bean scene to get Wi-Fi in Sunnyvale there. And I got introduced to, what's his name, Ken Thompson. And we chatted for about an hour or so. And the thing that he seemed to be most proud of that he's done more than the other things was actually regular expressions. And I've got some thing of him, but I got to say, I've never gotten into regular expressions. I find that most of my searches are too trivial for that. They're just a couple of things that I can't do. But let me get, what I wanted to do is go to, okay, this is actually the original challenge in this minimal expression group, and there's somebody's done a alternative, but it's all these 10-pointed stars, and you can see the oh, there's somebody got fancy. But definitely Brad's code. I sort of feel like I got to stick some of this stuff that's Brad done back at both the minimalist thing. One of the points I've sort of an outlier in the minimalist thing, because minimalist, the generally things that are even more minimal than fourth that people are dealing with. But I'm out here going and saying, look, there's also the issue of minimalism in terms of my time and in terms of the succinctness of the expression of what you're trying to do. And that's the math side. This was really the original one here, and mine's somewhere there. But I mentioned this on the British APL Association meeting the other day, and a guy went and presented this in APL. And I've started, I got back into this tri-APL, which is the whole thing, and started going through his construction of the thing and getting origin right and so forth, but that's his star. And this was a little bit of the stuff in between. I was trying to, this APL, one of the things I split to K and so forth, because it gets ridiculously complex to even figure out the parsing of the thing. I'll go and just show you what I did, but also show you the structures. Dyer gives the directory. I'm back over here, just in CoSy. That's the default directory, but I actually went and saved this. Here's a directory program. I think one of the things that I've appreciated is one of the very earliest aspects of CoSy is the fact that instead of the only difference between to go and tell the computer to execute a line is just going and hitting F6 instead of enter. But I went and let me throw again a comment symbol in here. CoSy Dyer is the essential there. It just made that word. Catenate, the CL is catenate lists. So, and then it just is freed. Let me actually go, and I've already shown that. I stored it as T0. So that's the script to go and define the stars. I finished it. And to evaluate it. Oh, yeah. I evaluated that script, so now I should have my star. And where's a line where I went and actually did a demo, or one of the, I brought my work, this is my workspace where I've worked on all of this stuff. So, okay, this was the one. I now have 8-star. That one's too complicated. There's actually, whoops, oh, I don't have it defined over here. Oh, here's what I wanted to get. This will do. That's one. Okay, here. This is the simplest one. Oh. Wrong. Wait, why did that not grab it? I thought I had. Yeah, this is the example that I want to do first. Yeah, here, one word that I've made, which is really quite trivial, but it's very useful, is I've used this left hack to just return the following thing as a string. Okay, so that's just my different characters that I'm using, and this takes a 5 off of the x86 stack and turns it into a 1-item vector. So those are my 2 arguments to S star. So okay, here's my star in terms, and I'm sort of disinclined to go through. Well, one thing I will mention in terms of the definition of S star here. Let me go. It'll be bigger if I go and is this big enough to read? I'd rather not. I just should have made that font bigger. No, as a matter of fact, let me just do it. I've got the stupid word here. 8 STAR and hell, let me just copy this. Because when I can see it, but it wouldn't really go. And let me. Yeah, this makes it somewhat bigger. But actually, the one thing that I wanted to point, and something that makes the APL shorter, is this actually, this 2p arrow says, okay, this function is going to have 2 parameters. And it's going to push them on the stack. It's going to use that stack thing to make a stack frame, and it also is reference counting, upping the reference count and so forth. So in here I have well, rfetch is whatever the right hand argument was, and lfetch was the left hand one, and those are the things that are right below previously on the stack. Those are what are on the stack. Those are those stack locations. And like I say, I've virtually never used, I've never really fleshed out the vocabulary for the locals. I almost did when I'm doing this, but one of the things is I use this A stack a lot, which is a reference counted auxiliary stack. So that handles the, and I find that better to use in many cases. And actually, I'm almost inclined to feel I'm done. Anybody got some questions? Because I'd really like questions.
Okay. While everybody's thinking about that, I want to ask you, are you done with your activity for today, or are you done with the asterisks? Which
I'm
done
sorry,
are you done with?
Let me stop you. What am I done with? Oh,
Are you done with your complete talk for today? Or are you just done with the Christmas star?
No, I thought I was done with it. I mean, first I started off by going and commenting on so I don't know. Yeah, again, ask me a question and
Yeah.
otherwise, hey.
Okay. We'll take anybody else with a question for Bob? Okay, going once, going twice. Right. The YouTube replaying. So I'd like to ask Bob. I'd like to ask anybody if they have any questions for Bob or anybody else.
Yeah, I'm wondering whether I didn't actually show the stars that I created, so I might as well do that. Where are we over here? Because yeah, here's my homepage, and one of the things that's nice. So this is actually my homepage now for Merry Christmas and related North Hemisphere winter solstice festivities. To go and keep the Christian foundation, and but make it for everybody. Oh, I don't have it. I didn't. Let me get back here and share my screen, because that was pretty pointless there. Here, this is what I was. Here's my screen. I was just pointing out my Merry Christmas, and here's just what I've got on the front page, and I've got a link to the fourth day presentation there too, which I didn't mean to jump to actually, and these little there we go back. I did want to go and jump to, there was another tree that somebody went and made, and I just, I failed to do this algorithmically, and so just did it by having a list of how long each item was, and then taking that many stars and then just centering it, which is a word. But here's actually what I sort of more or less did. First, I did it line by line, and I could go off, and this is the link to the where the original challenge was. But I did this. Matter of fact, actually, what I can do, because I made actually a little, well, I went through things line by line and executing that, and that made my star. And then I went and just did a field of them. But I actually made an MP4, so I might as well go and do that if I can expand that up enough. It's silent. But there it's going. You'll see. It's notes the page that the thing is on. And then it's executing. The first line produces the little thing. Then it flips it and puts it together, and then it makes this component. And then it puts the stuff together, and so it makes the whole star. And there's the line that makes the whole field. So I guess that completes that, unless anybody's got more of a question about that.
That's nice how you sort of composed each layer, and yeah, very nice.
Well, yeah, going back to that, actually, let me share again. Yeah, well, I got this over in my work log, which unfortunately well, it's fairly big font. Although I don't, this is where really one of the things is it took me a lot longer. Here's where it is to go through this line by line. And let me stop this stupid thing. The first line, I mean, I can just go and, okay, the tick, So it's got the star, and iota is the most, it returns the first 5 numbers or n numbers. And one of the things is it starts at 0. It's an address space. Give me an address space, you know, the index into 5, whatever. I like to think of it that way. It adds 1 to that. And then this defines a nameless function, if you will. And it does 5 take, and it does blanks, and it concatenates those on, and then this fill goes and fleshes it out. So at the first point, I've got this variable and its shape. This is the shape. It's a list of 5 lists, each of which are 5 long. It's padded out with spaces. And then reverse, essentially this line is just adding an extra space on each left, okay? It's got the space, it's concatenating again, and it's reversing each of them, and it's concatenating each line essentially. So that got that, and I don't know that it's worth and then flipping it, that goes in. Now I've got the vertical side, and then this I guess I've taken, and I must have, yeah, it takes the length here, and actually it's making the square. There's this section here, but putting the whole thing together, it's got that original, makes the square, and then it does another, it reverses this T2 again and adds it together, and so you've got the pieces. And then I don't see quite why something looks redundant there, but I don't know. That's plenty anyway. So, but I think actually one of the things that I really felt watching your stuff, Brad, I made a comment. Again, I'm not sharing my screen. I made the comment in my notes, which will be up. This presentation is up on the website, but your 4th haiku illustrates the power of 4th when as a language on arrays, when it's a language on arrays as opposed to scalars. You know, when you, and that's one of the things is, I'll tell you, I got to hand this back to a lot of my APL friends. Go and point them to your demo, because it can go and make them humble. Okay, I'll put it that way. It can really make them humble. Any other comments or whatever?
All right. Thank you very much, Bob. We appreciate
Kevin?
your, yes, go ahead, John.
Yeah, I'm in Las Vegas now, and some of the, I've got like 2 4th projects I might like to start. One is being able to translate C and C++ into 4th. Okay, and basically what it would do is just parse out, say, all the different C statements to be able to convert them into 4th, which means you'd have a lot of C code out there that you, instead of trying to do it by hand, you could do it, you just have a program that just does it for you. Okay, I think that would be a nice idea. There's a program called SVFIG that can accomplish that. And the other one is, as you know, Dennis Rufer is porting forth to include the real-time operating system Zephyr. I'd like to do the same thing with the R10s. That's a real-time executive for military systems. That's what the original name was. But also, I'd like to do is be able to come up with some high-level words that let you create threads, be able to control them. Same thing with inter-process communication, interrupt handlers, things like that. And have that all written in Forth, so that what you will get is you can have Forth with a preemptive real-time operating system, which I think would really be nice. It could be tested out on various architectures going through QEMU, and I think that would be a really neat thing to do. Be able to, say, write an application, have it run on a what's things called Raspberry Pi, something like that. I think that would be really cool. So I'm just going to be thinking about that, but also remember I have to work and have to get my place here all squared away after my uncle left it in such a mess. That's why I turned off my video. The place looks like hell. So yeah, that's the kind of stuff I'd like to be able to do. Plus, I've also have some astronomical stuff that I'm going to be doing with my classmate and professor. And also when the new semester starts, I'm going to be attending some talks at the Nevada Center for Astrophysics and see what's going on there.
Oh, yes.
yeah.
Astronomical instruments, so named because of their price.
Oh, yes. Yes.
All right. I think that I'd like you to talk about that some more in January. Would that be okay, John?
Yeah, February. Yeah, that'd be great.
No, January.
January, I'm sorry.
I said January. Did you want to move to February?
No. Let me just. I said I'm juggling a lot of stuff right now, so my brain's kind of frazzled right now.
So let's put you down for February, and we'll be in touch. Are you still at the same email address?
Yes, I am.
All right. I think I might have sent you something. It might have gone in your spam folder, I guess. I will be in touch with you. We ceremoniously start the recorder at the beginning and unceremoniously end the record. So Brad, I think it's time to pull the plug, and we'll see you next